Hello grade 9, how are you? This is Mr. Ahmed Samir, and let's continue with the revision sessions of geometry. I will start with position of a circle with respect to another. We have 6 positions of a circle with respect to another. First of all, if the distance between the centers of the circles greater than the sum of radii. Again, the first case, if the distance between the centers of the circles greater than the sum of its radii. Then, in this case, the two circles are called distant, and the intersection between the circle M and circle N equals phi. By the same way, the intersection between the surface of circle M and N equals also phi. The second case, if the distance between the centers of the circles equals the sum of radii, Mn, the distance between the centers of the circle equals R1 plus R2. In this case, the two circles are called touching externally, and the intersection between M and N equal the point of touching, equals the point A, and the intersection between the surface of M and N equals also the point A. Case number 3, if the distance between the centers of the circles greater than the difference between the radii and less than the sum of them. In this case, the circles are called intersecting circles, and the intersection between the circle M and N is the intersection points A and B, and the surface of circle M intersection the surface of circle N is the part or the intersection part between the circles. Case number 4, if the distance between the centers of the circle Mn equals the difference of radii, Mn equals R1 minus R2, in this case the two circles are called touching internally, and the intersection between circle M and circle N is the point A. The intersection between the out curve of circles equals A, and the intersection between the surface of circles equal the surface of the circle N, the inside circle N. Number 5, if the distance between the centers of the circle less than the difference between the radii, Mn, less than R1 minus R2, in this case, one of them inside the other, one circle inside the other, and the intersection between the circles equals phi, but the intersection between the surface of the circles equal the inside circle N, or the internal circle N. The last case, if Mn equals 0, the distance between the centers equals 0, then in this case the two circles are called concentric. Concentric means the center of circles are same. The center of M is the center of N. In this case, the intersection between M and N equals phi, but the intersection between the surface of the circles equals the surface of the internal circle N. By the same way, by another way, we can say that if the circles are concentric, then the distance between the centers equals 0. If the circles touching internally, then the distance between the centers equal R1 minus R2. Touching externally equals R1 plus R2. And we have cases equals intervals, like if one inside the other, then the distance between the centers, it will be the interval 0 opened to the difference between radii opened. By the same way, the intersecting circles, we can find the distance between the centers using the interval opened difference between radii and sum between radii opened. The last case, if the circles are distant, then the distance between the centers of the circles, we can find it using the interval R1 plus R2 opened and infinite. An example, let M and N be two circles. Their radii length are 4 and 9 respectively. Complete the following table. First of all, if the two circles are touching externally, we said that if the two circles touching externally, then Mn equals the sum of radii. It will be 4 plus 9 equals 13. Touching internally equals the difference between radii. 9 minus 4 equals 5. Intersecting, we will form an interval from the difference and the sum. It will be open interval 5 and 13. Concentric equals 0. Distant, from the sum of radii to infinite, opened, it will be 13 to infinite. One of them is inside the other. It will be from 0 to the difference of radii. It will be opened interval 0 and 5. Another question, complete the following. First of all, question number 1. If the surface of the circle M intersect the surface of the circle N equals phi. In this case, the two circles M and N are called distant or are distant. Number 2. If the surface of the circle M intersects the surface of the circle N equals A. In this case, the circles M and N are touching externally. Number 3. If the surface of the circle M intersects the surface of the circle N equals the surface of the circle N, then the two circles M and N may be concentric or inside each other. Concentric or inside each other. Number 4. If the circle M intersects the circle N equals phi, we have 3 cases for this position. Number 1, distant or inside or concentric. If the circle or the circles M and N, the intersection of them equals phi, so the circles may be distant, inside, or concentric. We will choose two from them. Number 5, if the circle M intersect N equals A. So in this case the circles are touching externally or internally. Number 6, the centered line of two intersecting circles is perpendicular to the common chord, and bisect it. Number 7, the centered line of two touching circles is perpendicular to the common tangent between them. Number 8, the axis of symmetry of two circles M and N that are intersecting at AB is, it will be MN, the chord MN or line segment MN. Number 9, if M and N are two centers of two circles of radii R1 and R2, where the distance between them greater than the sum of radii, then in this case the two circles are distant. Number 10, M and N two circles of radii R1 and R2. If Mn greater than the difference and less than the sum, so the two circles are intersecting. The last one, if the sum of lengths of two radii of two circles equals the distance between the two centers, then the two circles are touching externally.